record. Okay, so polarization, we're going to talk more about that in the next unit. But if you have polarized sunglasses and you're trying to look at a screen, those block some of that light out. That's why it's hard to see. So I'm wearing sunglasses, it's hard to see. You're gonna have to go without them, okay? All right, so just like the other day, as I go through any of this, unmute yourself if you have a question, or type it in the chat if you have a question, and I'll get those addressed. Okay, so the first thing I wanted to go over was the PHET lab from yesterday. Last I checked, a little more than half of you had submitted it. So if you're having trouble with that, please let me know. Try to get that done today if you can, so we don't fall too far behind. One thing with the file, like I said in the email, I was told that you wouldn't be able to edit or input values into a PDF. It looks like most of you figured that out. So I don't know if you put it right in the PDF or if you had to go to a PDF editor like I recommended. If you wouldn't mind, give me a little feedback on that. If you were able to edit it directly in your Chromebook, or if you had to go to the PDF editor. I'm trying to figure out how all this works. Some people opened it in Google Docs, and I tried to do that this morning so I could show you what it looked like. I couldn't figure out how to do that even, so I'm really behind on the technology. But if you open the PDF in Google Docs, it really messes it up. One student emailed me and says, I have no idea what the heck you're talking about here. So I eventually figured out that it was just not displaying correctly. There are ways around that. So please try to avoid opening PDFs in Google Docs. It may not look right. You know, like I said, I can figure out something to get around that. Some of you, it looked like you created it or converted it to a Word document and then typed in, hey, that's perfect. You know, I saw some submissions were Word documents. If you can do that, that is totally fine with me. You know, like I said, worst case, you just have to write out your answers. Hopefully we can figure out how to avoid that. But okay, so I see Nahida finished it directly and then put your answers, took a screen cap on it, turn in like that. Okay, that's fine. Yeah, I mean, if you can enter it directly, you can just save it and then submit that saved file, and that works as well. So you don't need to do the screen capture. Okay, and Annabelle was able to enter it too. So it looks like some people might be able to PDF. Oh, wait, computer deleted all my answers. Oh, Anna, sorry. Okay, so Noah copied and pasted the whole thing in a Google Doc. And I assume that worked for you, Noah. Doesn't say for me, I think, because I'm on my home laptop. Home laptop, it should work. The Chromebook is what I had a concern with. So the laptop should work, but whatever you need to do. I mean, you guys are pretty good with technology, but don't stress out about this. If I gave you something, a file that you can't open, or if you can't figure out what to do, let me know and we'll figure it out. Okay, so Sarah opened PDF, mail typed in directly. Had to submit it with pictures. That's fine. Yeah. Okay. I want to avoid having you write it all out by hand. And I see, a couple of you had to do that. So in the future, if we do another one of these, let me know and we'll try to work with each other and figure that out. So, okay. So anyway, I want to go through this lab real quick. Some of them look good. Some of them, I noticed some mistakes. So we'll see what we have here. Okay. So the first thing, your answers here, you should have seen about 7.5 centimeters, about 30 seconds to go back and forth 5 times. So again, that's 1, 2, 3, 4, 5, or however you counted that, and then divide that by 5 to get your answer there. Okay. So then this low tension row is basically what you just did, because you had it set on low tension, no damping, fixed end pulse. So you filled that in there. The speed of the wave, okay, this is where, okay, the speed of the wave, speed is distance over time. And I had a couple questions on this. Your distance and time have to go together. So you have the time to travel one length, time to travel one length. So you then need the distance for one length. So you're taking this distance divided by that time to get the speed. So you should have gotten similar numbers to these, okay? So at a quick glance, a lot of you look like you had that okay. So that was good. Now the conclusion here is as you go to a higher tension, you see the speed increases. Okay, so higher tension means the faster that wave is going to travel. So that's my conclusion down there. And by the way, I'm going to put this, I'll save this as a PDF. I'll put this on Canvas so you don't need to worry about scrambling and taking any notes if anybody's trying to do that. Okay, all right, so that's part one. All right, no chat questions there. And then part two, so this is where you did things a little differently. This is where you had the periodic or traveling wave and it went out the window. All right, so you're still doing similar things, but a couple additional things here. Okay, so the time to travel one length, so you just watch the wave travel across the screen like that. And I think everybody was okay with that. You know, it suggested put it in slow motion, easier time that way. Distance for one length, well, that's still the 0.075 meters. That's still a 7.5 centimeters. The wavelength, this is where our answers may be slightly different, but not much. Okay, so the wavelength, you'd have to move that ruler around. And remember, you're looking for one complete wave. Okay, so just from a point on the wave to the next identical point on the same wave. So our wavelengths should be pretty similar as we go down here. Speed, again, speed is distance over time. We don't have the time for one wavelength. Remember, that's called period. We don't have that. We have the distance for one length and the time for one length. So these are the two you're using to get that speed again. Okay, and then the last column, frequency times wavelength. Okay, so frequency, if you remember, that is waves per second, and then times wavelength, well, that's going to be in meters, basically. Okay, now the thing with frequency, it's a little weird. Waves really is not a unit. Okay, so really we could say cycles per second or hertz, which is 1/seconds. Anyway, if you multiply these, you do get units of meters per second. So that's what I was looking for, the units there, meters per second. If you take frequency times wavelength, frequency is 1, wavelength, I measured about 0.0122, so I got 0.0122. Okay, so anyway, that's the process here. You follow that same process all the way down, repeat low tension 2 hertz, 3 hertz, go medium tension 1, 2, 3, high tension 1, 2, 3. One thing I wanted you to notice, sorry, there's just a cute little puppy walking by. One thing I wanted you to notice is that these two columns, the speed and the frequency times wavelength, are the same. Okay, so 0.0125, 0.0122, pretty much the same if you look all the way down. And this is my data, yours is going to be a little bit different, but these essentially are the same. So the conclusion here is speed equals frequency times wavelength. I talked about that in the last video anyway, so hopefully that was pretty straightforward. The other thing I want you to notice is as you change the frequency within a low tension, we already saw that the tension changes the speed. So let's look within one tension. We look at the speed is identical. Okay, so 0.0125, 0.0125, 0.0124, pretty much the same. Medium, 0.0364, 0.0369, 0.0369, the same. High tension, the same. Okay, so the questions down below, then tension remains constant, frequency increases, what happens in wavelength? Well, it's a visual. If you increase the frequency, you're going to have a shorter wavelength. Okay, so let's say you have a wave like this. That's a certain frequency. If we increase the frequency, it's going to be something like that. So you have a shorter wavelength on that. Next question, the last two columns, I just talked about that. They should be the same. Okay, speed is frequency times wavelength. Relationship between frequency, wavelength, and speed, This I talked about in the video, so hopefully you all got that. Speed is frequency times wavelength. Frequency does not affect the speed. You know, look back at the data table. Within a certain tension, the frequency did not affect the speed. And then the other thing, amplitude. I didn't have you take data on that, but if you play around with the amplitude does not affect the speed either. Okay, so if you saw that it did, just go back to that simulation real quickly and just kind of take a look at that. You know, change the amplitude, a small amplitude and big amplitude, time how long it takes to go across. You're going to see it's not going to affect the speed. Okay. That's a summary of that lab. So this is a big thing I wanted you to get out of it, and this and this. Okay, those are the big conclusions here. All right, I guess this as well. And this is because speed is constant. So we have V equals F lambda. If speed is constant, if frequency increases, wavelength will decrease, and vice versa. Okay, any questions on that? I'm seeing nothing in the chat. I hope you're all still with me. 23 participants. All right, I got 23. Okay. Oh, okay. My dog hates delivery trucks for some reason, so he has to go bark at him. All right, I'm gonna stop this video. I'm gonna post it separately. So, I'm gonna stop the recording.